Introducing IC2, the autonomous robot to spread climate awareness to the public in the most hilarious way that people truly pay attention. Take a look at this robot illustration. The IC2 robot is composed of two major parts, known as the message broadcasting system and the motion maneuver system. Before I explain further about the IC2, let's take a quick look at its design. The message broadcast system consists of four subcomponents: human detection, image capture, image captioning, message generation, and message broadcast. The purpose of detecting human presence is to avoid continual message broadcasts, even when no one is listening. Take a look at this example. Just imagine how sad it would be for the robot to talk when no one's around. Poor robot. The Raspberry Pi camera on the robot continuously captures video frames from its surrounding and sends these captures to the Raspberry Pi microcomputer for object detection. The Raspberry Pi uses Google's MediaPipe object detection model to detect the presence of humans. And in the case of a positive response, meaning that there's at least a person, the Raspberry Pi starts sending video frame captures periodically for image captioning. Image captures are sent to the Blip API, which returns a block of text related to what is happening in the photo. This image here, for instance, generates the caption, "There is a man holding a box in front of a robot statue." The next step is the message broadcast system is to use the ChatGPT API to generate a message that raises awareness for climate change. To stimulate people's interest in the message, the prompt asks for a funny command about the cause of climate change based on the image caption. Furthermore, we emphasize that the message should also specify a positive tone or a negative tone. After ChatGPT returns the climate change awareness message, we convert this block of text into an audio file using NVIDIA's Arrival text-to-speech generation model. This model provides prompt audio generation within 3 seconds for a two-sentence text and decent naturalness of voice. This audio file is broadcasting using a small microphone located at the top of the robot. As the robot is broadcasting its message, it will stop moving. In addition to the regular message system, the robot will also have a greeting feature. Upon auditory cueing from a person, the robot will broadcast "hello," followed by a criticism message broadcasted to the person, generated through the process described previously. IC2 is designed to independently moves around a designated area. The robot first moves around a designated area via remote control to map available paths. It uses a lidar range sensor at the top of the robot to detect obstacles in its path, and a rotating lidar sensor at the bottom of the robot to detect elevation changes in its path. After a map of the designated area is generated, the robot can start moving around and the map autonomously while trying to avoid obstacles and sudden elevation drops in its way. The autonomous driving system will be exploring the designated area infinitely until it runs out of battery or if it encounters a person to interact with. The robot will consistently monitor its surrounding for obstacles and sudden elevation changes and try to avoid them, while trying its best to maneuver back to its designated area. Now, you can see a fully working IC2 being so happy because now it can spread climate awareness to people. As we stand at the intersection of robotics and climate awareness, we are reminded of the immense potential that lies ahead. The road is long, but it's the one we're committed to traveling. Our robot project is a small but significant step towards a more sustainable, and informed world. So, let's continue pushing boundaries of technology, fostering collaboration, and raising climate awareness with unwavering determination. Thank you for being a part of this journey, and let's strive to leave positive mark on our planet.